We are live. Hi everyone, welcome back to Code Era. Today in this video we'll be discussing the Leetcode daily challenge for 26th of January, that is for Republic Day. So it's a Republic Day special problem, and this problem name is all elements in two binary search trees, right? So in this particular question you'll be given two binary search trees, and you have to return, in the end you have to return all the elements of these binary trees in a list or in a vector such that they are in sorted order, right? Or they are in the ascending order. Like if you have something like this, if you have 2 1 4 and if you have 1 0 3, in that case ultimately you will return 0 1 1 and then 2 3 4, right? So if everyone is able to hear my voice and my screen is also clearly visible, so consider giving a quick +1 in the chat, and then we'll start with this particular problem, right? Okay, you can just consider giving a +1 in the chat if my voice is clearly audible to everyone, and then we'll start with this problem, right? So this problem has been previously asked in organizations like Facebook, which is now also known as Meta. So how many of you have solved this problem? Let me know in the comments, right? So this is a Facebook interview problem. Oh, what's happening? Let me write this. So it is a Facebook interview problem. And what you have to do is you will be given two binary search trees, and ultimately what you have to do is you have to collect all of their data that is there, all the values, and ultimately you have to return a vector or a list, and which is containing all the data in sorted order, or you can say specifically ascending order, right? You have to return it like that. Is the problem statement clear to everyone? Just quickly let me know in the chat. Is the problem statement clear to each and every one of you? Then we can proceed further, right? Okay, like if let's say the sample example that has been given to us, if it's something like 0 2 1 4 and then 1 0 3, right? If it's like 2 1 4, and what's the second example? Second example is 0, then 1 and 3. Okay, this is the second one. So if these are the two trees, these are the two binary search trees that we have, that is the first binary search tree that we have is this one, and the second binary search tree that we have is this one, right? So in that case, what will you do? This binary search, if you tree from this, you have 1 2 and 4. From this binary search tree you have 0 1 and 3, right? So these are the things that you have from them. So ultimately if you will combine some, this will look like 0 1 1 2 3 4 in the sorted order, right? In the sorted order. I hope that this much part is clear to everybody, right? Is this much part clear to everyone? I hope that this much part is clear to everyone, right? Is it clear to everyone? Okay, right. So what you could do is, first of all, what you could do is, like you have two binary search trees, right? So what you could do is you can traverse, you will say that in the naive manner or in the basic manner, what you will get is that maybe what you could do is you could have both their data, you can traverse both, right? You will say that we can traverse both, and then like put all of the data in a vector, right? Let's say you have this binary search tree that is 2 1 and 4, and you have 0 1 and 3 like this, right? So what you could do is you keep on traversing them in with any type of traversal. You can either do a DFS, you could do a BFS, you could do a pre-order, you could do a post-order, any order, and you store all the nodes, right? Like 1 2 4 and then 0 1 3. I store all of the nodes, and then what I do is I simply sort the given this complete array. That is, it would become 0 1 1 and then 2, then 3 and then 4 like this, right? So this is how it would become. So this is what, this is nothing but, this is a sorted answer that we wanted, right? So in this particular approach, what would happen is to traverse the binary search tree, right? Since you have two binary search trees, so you would be traversing each of them, so it would take order of n time plus order of m time for traversing each binary search tree. And since you are also sorting, so it would take order of m plus n, log of m plus n time, right? Order of m plus n, log of m plus n time, because you are sorting the complete vector, right? If this much part is clear, you can consider giving a quick +1 in the chat, right? This much part must be clear. So this is one of the ways, right? This is the first way to do this problem. Now there is a second approach as well. So if you have binary search tree, right? If you have a binary search tree, right? If you have a binary search tree, let's say the tree is like this, uh, and then like you have here you have 4, and here you have 0, 1 and 3, something like this. If the tree looks like this, then in that case we know that the in order traversal of a binary search tree, that in order is what? First of all left, then root, and then right. So in order traversal of a binary search tree gives us what? The gives us the data or all the nodes in the ascending order, right? In the ascending order. What do I mean by that? Let's try to do the in order traversal for this particular tree. So if I am at this particular node, in that case if I go towards its left, so I'll be at this node, then I go towards its left, then I am at this node, I check whether it has a left or not, it doesn't have. Whether this has a right or not, it doesn't have. So I'll be pushing it into a vector. So now I'll push it into a vector, so that will be 1, right? After that what would happen? I'll go back up, right? Because I have to call for the right child. So I'll call for, like, before calling for the right child, I'll store the root. So that's what I'll do. So I'll store 2. After that I'll call for the right child. Since this right child 4 is not having, all of you who have joined this stream, please consider giving a quick +1 in the chat, right? If up till now the question is clear. If you want me to repeat, I can repeat as well, right? So next up you have this thing. So you will write 4 here, right? I hope that this much part is clear to everyone, right? Now with this particular tree, that the same approach would happen, that is left, root and right. So I will be at the current root, so I go towards its left. With this I see there's no left, right? So after that I'll write its root, so the root is 0. After that it does not have a right, so that is why I'll go back. This is my root now, that was my root earlier, because for this I called for the left. So I'll write 1 here. Once I have my 1 here, what will I do? I'll check for the right. I'll go for the right subtree, so I'll go for the right, and this right does not have a left, so that's why I'll write the root first, and then after that it does not have a right, so my iteration would stop, right? So if I have these two arrays, that is these 0 1 0, like 1 to 4 and 0 1 3. So in that case, now if I have this and this data, so one vector is having the data of the first array, and the second vector is having the data of the second array, right? So in this particular case, what could I do? I could simply mark one pointer I to this point and one pointer j to this point, and I would make a vector which is of size, which is of space complexity, which makes my space complexity order of n plus m, because I want to, this is n size and this is m size, right? So I'll add these two. I'll push all the elements into this vector. So let me have it, right? So what I'll do is I'll check, this is my first array, this is my second array. So which element is lesser? Like this is, let's say this is array A, this is array B, or this is, let's say, tree 1 or tree 2. Let's name it like that, right? This is nothing but my tree 1, this is nothing but my tree 2. What will I do? I'll check this 0 is lesser than 1, so that's why I'll first of all put 0 here, right? This is nothing but, this is the concept of merge two sorted arrays in order of n plus m time, right? In linear time, you can say, right? So that's what I am doing. Now what I will do, my j would stop, my j would point here, and if my j is pointing here, so my I and j both are equal, so it does not matter which element I'll push. So I'll say that, okay, I'll push this one, and then let's say my j moves here. After my j moves here, so what will happen? This element of the first tree is lesser, so that's why I'll push 1. Once I push 1, so it will move from this element to this element. Now my I is at 2, so I is pointing to 2 and j is pointing to 3, so definitely I'll push I, that is the element 2, that is array of I or tree of I, tree 1 of I. After that my I moves to this 4, so j, the element at the jth index is 3, so that's why I'll push it, and j moves out of the first array, so j finishes, and after that I just have a 4, so I'll push it, right? So if there is any array which is left, which, let's suppose that if in this array you had 5 6 7 as well, so you would have just checked that if there is both the arrays, if any of the arrays among both of the arrays, if any of the arrays is having some elements left, so in that case you would have pushed the leftover elements, right? So if this much part is clear, so you have understood the question completely. So this question can be broken down into two parts, right? What you had to do was, you were given a binary search tree you were given two binary search trees and you had to combine their data, and you had to return the everything in ascending order, right? If up till now things are clear to you or you are present, so you can consider liking the video or give a +1 in the chat, so that I know that at least you are here, right? Okay, so in ascending order you had to put all the data, you had to present all the data. So this question is nothing but a combination of two questions, right? What you have is, you have to do the in order traversal. First of all, you have to do the in order traversal for the tree. Why would you do the in order traversal? So that you can get the tree 1 and tree 2 in ascending order, right? After that, after you have tree 1 and tree 2 as vectors, this is a sorted vector, this is also a sorted vector. So after that, what you would do, this is the first thing that you would do. And now secondly, what you would do is, hi Shreya Singh, secondly what you would do is that you would simply merge, you'll apply the concept of merge to sorted arrays, right? Is this much part clear to you? Shreya, is it clear to you? If it's clear to you, Shreya, then you can write clear in the chat and I'll understand that you have understood this question. Basically, we have been given two binary search trees, and this question, this was a Facebook question, right? This was a Facebook interview question. In this, you have been given two binary search trees and you have to collect all the nodes data that is present in both the nodes, and ultimately you have to return all the nodes data in ascending order, right? So one way could be that you traverse both the trees in any order and you push all of them into a vector, and then you just simply sort them. So that would take order of n plus m, log of n plus m time complexity, right? Because that will be nothing but total elements, and then you are sorting, right? After that, this could be the second approach, could be that you first of all apply the in order traversal and you store the representation of the first tree in a vector, right? So that would be in order traversal of a binary search tree is in sorted order, right? So that's why it would help. Now after that, what will happen? After that, I do what? After I have both the arrays, both the representation of the binary search trees in a sorted manner, right? So in that case, what would happen? I simply have to apply the concept, that is merge two sorted arrays, right? Merge two sorted arrays, and I know that this can be done in order of n plus m time. So that is how I'll be doing it. Let me show you the code part for this particular approach and how we'll be doing it. So what I would be doing first is, I'll be getting the root of the first tree and the root of the second tree, right? Shay, is it clear to you? You can just write a yes in the chat if the problem statement up till now is clear to you, and everyone else who has joined, if it's clear to everyone, they can just like the video and hit a +1 in the chat, right? So what I will do, I'll declare two vectors, first for the tree 1 and second for the tree 2. I'll call the in order traversal for the first tree. So in that in order traversal, what I will do, if the root is existing, if the root is not null, so I'll call it for its left child, and then I'll push back the root. That is nothing but in order traversal is what? Left root, right? So that is what I am doing. So in order traversal, I'll call for the left child. Then after that, I'll be pushing my root in my vector root value, and then I'll call for the right child. This is what I am doing in my in order function, right? In order traversal function, right? After that, I'll call it the same in order function for my second tree as well. And once I have it, so what will I do? I'll call a tree, that is, I'll make a new vector that will be of size n plus m. Ankit Kumar, is this question clear to you? I hope that it's clear to you, right? After that, what will happen? I'll simply make a vector of n plus m size. So that is why I'm taking tree 1 dot size and tree 2 dot size. After that, I'll call a function merge two sorted arrays, like something like that. So you can name your function anything. So this is nothing but merge vectors function, in which I want to merge the data of the tree 1 and the tree 2 in the merge vector array, right? So what I would be doing in this part, I'll mark my I as 0, j as 0, and k as 0. I would be pointing to the elements of the first tree. J would be pointing to the elements of the second tree, and k would be pointing simply to the elements of the final merged tree or the merged array that I want to have. So if I is lesser than n and j is lesser than m, in that case, if the first if I is pointing to an index such that the element is lesser, so in that case I'll say that okay, I'll be inserting, first of all I'll be inserting the ith element of the first vector, and I'll do a k++ and I'll do I++ so that they can get updated. Otherwise I'll be doing this, that is, I'll be inserting the element j first, element at the index j first from the second tree, and then I'll be updating my indexes like this, right? If there is, after the traversal is over, if any of the arrays is still empty, in that case, like if it still is not empty, if it is not reached its end, either this would happen or that would happen, right, depending on the case. So in that case, I'll insert all the leftover elements into my merge vectors, and in the end I'll simply return my vector. If this question is clear to everyone, please write clear in the chat or give a +1 in the chat, and also like the video, right? So this question I hope is clear to everybody. Now previously this question was asked in an organization like Facebook, right? Facebook, or now it is also these days known as Meta. So you can try this problem out, try out this problem, try to submit this problem out, right? It was nothing but in order traversal plus merge two sorted arrays, right? Two sorted arrays concept, and we have done this in linear time. So the time complexity for this particular approach would be order of n plus order of m plus order of n plus m, right? This is what would be the time complexity, traversing the first tree, traversing the second tree, and then merging two sorted arrays, right? After that, the space complexity for this particular question would be order of n plus m, right? Because we are ultimately returning a vector which is n plus m size, right? That is containing nodes of both the trees, right? If this much part is clear, you can consider giving a +1 in the chat. Also, one more thing, once you submit this particular problem, so come back to this video and give us a +1 in the chat, or write submitted in the chat, right? So that I know that you have submitted the Leetcode daily challenge for today. The code and the problem link are available in the description of this video, so you can try the problem out by yourself as well. It's a Facebook question, so it's not asked in any simple company, it's asked in a good company, so that's why you can have a look at this particular question. Now talking about this thing, so that's it for today, and I hope that you liked my explanation. Thanks a lot everyone for joining.